Okay, welcome back. We're here now on section 2.3, and what we want to do is be able to how to recognize and graph linear functions. So a couple different ways we're going to go about that is if we're given a table of values, one thing we know about linear is that we have a constant slope. The slope doesn't ever change. So what you do is you check this change in y, or change in f of x and y are the same thing. Make sure that that stays the same. And as we can tell here, our y's are going down by 1. At the same time, our x's are going up by 2. So our slope between each one is going to stay the same at negative 1/2. So as long as that slope stays constant, then we know that this would be an example of linear. When in doubt, you can always graph it too, and if it looks like a line, it's linear, obviously. Okay, now this is an example of one that is not. Now the x's are going up by 1, that's good. But the y's, or the f of x values, they're going up by 2, then up by 4, then up by 8. And so our slope here is 2, but our slope here is 4, and our slope here is 8. Well, that's changing, that's making that line curve, so that's not a linear equation. It's got to be the same every single time. So that's a good way to check that. And again, just kind of keeping some things in mind. Slope, remember, it's the change in y over the change in x. It's the rise over the run. We can always think of it as that, as slope. Okay. So graphing, let's look at a variety of ways of graphing. If we give you a point on the line and the slope of that line, we should be able to graph that pretty. Start with the point -1, -3, put a dot there. Now the slope tells you the rise over the run. So from that point, go up 5, and then to the right 2. 5/2, that's the graph. So all you need is 2 points, draw a dot-to-dot shot, and you're good to go. All right, what if we have something like this? We have a point 0, 2. There's the point. Now the slope is -3/4, so what we're going to do here is we're going to go down 3 and to the right 4. Now we could go up 3, but then we'd have to go to the left 4. Negative sloping lines, remember, have to go downward. Okay, positive slope upward. Keep that in mind when you graph those. Okay. All right, some other ways is to graph is by looking at the intercepts. If we can figure out where it crosses the y-axis and the x-axis, we're good. We can just do dot-to-dot shots with that. Well, take a look. When we cross the y-axis, the value of x is going to be 0. So to find the y-intercept, we're just going to put a 0 in for x. Now, also, when we look at the x-intercept, well, that's where the y values are all 0. So to find the x-intercept, we're going to put a y in for 0. And I call this method the duck and cover method. All right, so let's find the intercepts. Well, let's find the x-intercept first. We put a 0 in for y, so essentially just covering that up. Well, 4x equals 16, so then x would have to be 4 if we solve for x. And there we go. We'll put a dot at 4. Now, the y-intercept is if we cover up the x, duck and cover. And if we divide by 2, we'd see that y would be, well, 16 divided by -2 is -8. And there we go, dot-to-dot shot. So we can find the intercepts rather quickly by using that method, and then we can just graph it from there. All right, let's try another one of those. All right, in this case, all right, let's find the x-intercept first. We're going to cover that up. Well, -24 divided by 6 is -4. And if I cover this up, well, negative divided by negative, it's going to be +12. There we go. Those are our 2 intercepts. Dot-to-dot shots, and we got it. So remember, it's just like putting zeros in for those, and those give you the intercepts. All right. The other thing that we have here is slope-intercept form. And that's kind of a big one here. We're going to go y equals mx plus b. M, the number in front of the x is going to be the slope, and the number by itself is going to be the y-intercept. So if we know those two things, we can come up with the graph fairly easily. All right, so we have to put it in that form. So we have to get y by itself. So what we're going to do is we're going to add a 4x to the other side. And there we go. It's in slope-intercept form. That was pretty easy. So we're going to start at the y-intercept of -1. And the slope is 4, which is like 4 over 1. So we're going to go up 4 and to the right 1. There's a dot, and we got it. All right, so that's pretty nice. So solve for y. That puts it in that slope-intercept form. Let's try one that's maybe a little tougher. All right, in this case, let's subtract the x. So we have 3/4 y is equal to -x plus 6. Okay. All right, well, now we're going to divide by 3/4, but it's the easier way of doing this is to multiply everything by 4/3. Multiply by the reciprocal is what you do. So y is going to be, well, -4/3 x plus 2, that would have to be 8. So we'd start at the y-intercept at 8, and our slope is -4/3. Go down 4 and to the right 3. And there we go. It's a little tricky one. That one's still tougher with the fraction in there. So But again, getting that y by itself, we can do that. All right, and last but not least today, we're going to talk about, well, what if we have vertical or horizontal lines? Well, here's a vertical line, and that is going to be if you ever have x equals a number, like in this case, this would be where x is equal to 1.5. Those are all of the x values. Now, you'd think x would be horizontal because that's the axis, but actually no, it's a vertical line because these are all the x values where they are 1.5. And the y-intercept, or the y, if it's a horizontal line, it's going to be y equals a number. In this case, 1, 2, 3. This would be y equals 3.5. Okay, so if we go back to our slope-intercept form, that kind of makes sense, is that a horizontal line has 0 slope, so that way there's no x there. So basically all you have is your y-intercept for the equation of that line. So remember, hiya, that's if we have x equals a number. That's if y equals a number without an x. No x is there, okay? All right, so there we go. Those are linear equations. We've got graphing on those. That's section 2.3. Until next time, I'm Mr. Moon.